All right, in today's video reference, we're going to look at a new topic, our last new topic of 8th grade this year, which is exponent rules. So we're going to go through some guided video reference notes, and the first thing we need to look at is the actual terms that we're going to use. So says 2 to the third power. So when you look at this, this number, this little 3 is actually called your exponent. And this number 2, the bigger number, is your base. Okay? So exponents show repeated multiplication. Okay? So basically 2 to the third, hopefully you know, does not mean 2 times 3. It means 2 times 2 times 2, which is 4. 2 times 2 is 4, times 2 is 8. Okay? We've done that before for the most part. So then there comes different rules that you can use to simplify these different exponent expressions. So the first rule is called the product rule. And basically, really important thing is that it has to have the same bases when you use this rule. So same bases means this number has to be the same in both expressions. So, and you have to be multiplying. So if you're multiplying x squared times x to the third, you can see they both have the same base of x. Watch what happens. If you write that all out, that's x times x, and then times x times x times x. Really, how many x's do you have there? It's x to the fifth. Same thing if you had a to the fourth times a to the fifth. Same bases being multiplied. That's a to the fourth times a to the fifth is really just a to the ninth. So say I did that with numbers. Say I had 2 to the second times 2 to the third. That would really just be what? Yeah, add the exponents to the fifth. Why? Because it's really 2 times 2 times 2 times 2 times 2 is to the fifth. So the rule basically states that if you have the same bases being multiplied, just add exponents and keep base. Okay, so that's the first and probably the easiest rule out of all of them. Then we have power to power rule. Okay, so I would refer back to He-Man if we were in class. It's an old TV show I used to watch, and the guy would be like, "I have the power," so it's power to a power. A little Arnold Schwarzenegger there too. So basically, what this is saying, right, is taking x squared and raise it to the third power. So you do like x squared 3 times. And what did we just learn from the last rule? That is really x times x times x times x times x times x, which is really x to the sixth. So what did you really just do there? You added 2 3 times. What is really adding 2 3 times when in math? You're multiplying 2 by 3. So same thing if I had m to the third times m to the fourth. It's m to the third times m to the third times m to the third times m to the third. And we just learned that if they have the same bases, you can just add those exponents. And if you're adding 3 4 times, what are you really doing? 3 times 4, which is m to the 12th. So all the power to the power, or the power rule is saying, is if just multiply the exponents and keep the base. Sorry, keep the base. So if I did that, I didn't do one with numbers. So say I had like 5 to the third raised to the fifth. That would be 3 times 5 is 15. So that would be 5 to the 15th. Cool. The next one is the quotient rule. So quotient is a fancy word for division. And sometimes we show division with a fraction line. Okay? So what happens here with the quotient rule, again, you notice this only works when the bases are the same. Okay? So what happens here, if I was to expand this out, x to the fifth would really be x times x times x times x. 1, 2, 3, 4, 5. X to the third. 1, 2, 3. So really, in math, what happens is that you can cross simplify or cancel out some of these. So this would cancel out because it's just 1. Like 5 divided by 5 is 1. 4 divided by 4 is 1. 3 divided by 3 is 1. So whatever these x's are, they would just be 1 and simplify or cancel out. So you'd really just be left with x squared. How can we make 5 and 3 turn into 2? 5 and 3 turn into 2. Hold that thought. What about if we add a to the sixth? 1, 2, 3, 4, 5, 6. Over a to the third. Okay, cancel, cancel, cancel. I'm left with a. Oh wait, hold on. Yeah, a to the third. There are 3 a's left. So how would I make 6 and 3 turn to 3? Hopefully you're noticing you just subtract. So really, the rule is if it's the same bases being divided, just subtract the exponents. So I'll write that here. If same bases being divided, just subtract exponents, and of course keep the base the same. All right, so let's do a number example because I didn't do one of those. Let's say I just had tomorrow is the 22nd, so we'll do 5 to the 22nd, which is a ginormous number, over 5 to the 12th. Okay, so if you keep the 5 and subtract 22 minus 12, this would be 5 to the 10th, which again is a ginormous number. Let's see if we'll go on to the next rule or if we'll just leave it. I don't want to do negative coefficients, so why don't we just call that reference for today? I don't want to do negative, dealing with negatives yet. What else is there? The zero exponent rule, that's easy, but I think we can do that a different day. So we've gone over 3 rules today in distance learning. We've done, just to recap, and I actually have it here. I'm going to include this in the PDF today. Where is it? This does a nice job explaining the rules we just did today. So here's the first rule we looked at. Product rule, same bases, add the exponents. So you just do m plus n, and if, for example, x to the fifth times x to the third is just x to the eighth. We did the quotient rule, which states same bases, subtract the exponents. So you do m minus n for the exponents. So like x to the ninth or x to the fifth is x to the fourth. And then we did the power rule, the first one, which is just power raised to a power to a power, multiply the exponents. So here you can see x to the third raised to the fourth is 3 times 4, which is 12. That's a good start to get us going. I think I have, again, it's more redundant, but examples here. The product rule, again, just add the exponents. 3 plus 8 is 11. 4 plus 2 is 6. Quotient rule, subtract them, and then there's another page. Where's the power to a power? Multiply them. Okay, so that's today's video reference. I'm going to put some easy multiple choice in our forms for today, so that way we have some practice. And tomorrow is Back to the Future Day, so we'll be hearing a little bit of this song here. Or not. Okay. And then the other thing, I did invite Michael J. Fox on Twitter to come to our hangouts tomorrow. I don't think he's coming. See you guys tomorrow.